Hello everyone, I am Raphael with NovaStar. Welcome to the NovaStar Certified Engineer Training Session Level 1. This training session is the basic course and aims at participants who have less experience in the LED industry. Hence, in this course, they will know about what the common interfaces used in the LED industry. Alright, let's get started with the video signal interface. The first and one of the most common one is HDMI. HDMI is the abbreviation for High Definition Multimedia Interface. It is a digital replacement for analog video standards. Well, here are some common HDMI interface standards. The bandwidth for HDMI 1.3 is enough for Full HD, which is 1920 by 1080p at 60 Hz. As for 4K at 60 Hz, which is 4 times the Full HD resolution, we can use the HDMI 2.0. As for 8K at 60 Hz, then it is HDMI 2.1. Sometimes you might see HDMI 1.4 in LED processors. You might wonder what resolution can HDMI 1.4 achieve. Its bandwidth is twice the HDMI 1.3, so it can handle 2 Full HD at 60 Hz, which is 4K by 1K. If you want to lower down the refresh rate by half, you can get a 4K resolution at 30 Hz by HDMI 1.4. Well, here comes the question. What is the meaning of 30 Hz and 60 Hz? Before we understand this question, we need to know what the refresh rate is. The refresh rate is the number of times a display updates its image per second. This is measured in Hertz. The higher the number, the smoother the image will appear, especially during the fast-moving scenes. Hence, 30 Hz means display updates its image 30 Hz per second, while 60 Hz, 60 Hz per second. The higher the refresh rate, the less the bandwidth is left. So you can see within the same certain bandwidth, the resolution and the refresh rate is mutually exclusive. Alright, let's look at the second one, DP. DP is the abbreviation for display port. It is primarily used to connect to a video source to a display device, such as like a computer monitor. It can also carry audio, USB, and other forms of data. Display port was designed to replace VGA and DVI. Here are some common DP interface standards. DP 1.1 can handle Full HD at 60 Hz, and DP 1.4 can handle 4K at 60 Hz, while DP 1.4 can handle 8K at 60 Hz. A third one is DVI. It is the abbreviation of Digital Visual Interface. The digital interface is used to connect a video source, such as video display controller, to a display device such as like a computer monitor. It was developed within the intention of creating the industry standard for transferring uncompressed digital video content. DVI devices manufactured as DVI-I have supported for analog connections and are compatible with the analog VGA interfaces by including the VGA pins, while DVI-D devices are digital only. The single-link DVI can support up to a Full HD at 60 Hz, which is similar with HDMI 1.3, while dual-link DVI can support 4K by 1K at 60 Hz, which is similar with HDMI 1.4. Here is the SDI interface, which is usually used in camera and broadcasting. It is the abbreviation of Serial Digital Interface. It is a family of digital video interfaces first standardized by SMPTE. Here are some common SDI standards. 3G SDI can handle 1080p and 12G SDI can handle 4K. The last one is VGA. VGA is the abbreviation of the Video Graphics Array, which is a video display controller and accompanying de facto graphics standard. Well, apart from video interface using LED controllers, here are some common controlling cables used for LED controllers. USB cables is the most common controlling cable used in the LED controllers because it is ready to use when you're plugged in. Ethernet cable can also help control. T5688 and T568B are two different standardized ways of ordering the individual wirings inside of the Ethernet cable. The A type is designed for backward compatibility with the older telephone wires, and the B type is designed for better signal isolation and noise protection for newer networking system products. So you need to choose the B type line sequence for controlling the PC. So as you can see from the picture, the line sequence for T568B goes from orange-white, orange, green-white, blue, blue-white, green, brown-white, and brown. The last one is mostly used for transmit data. That is fiber. Here is the commonly used fiber optic connectors in the industry. Here are the LC connectors. So to sum up, HDMI, DP, DVI, SD, and VGA are the common video interfaces for transmitting data. And USB and Ethernet cable are transmitting controlling signals. Ethernet cables and fiber can help transmit the pixel data. Well, apart from that, we might need also to know some basic concepts of the LED industry. Well, the first one would be pixel. Pixel refers to the smallest unit on the LED screen. Each red, green, and blue pixels can work together as a unit and mix out multiple colors. The second one would be pixel pitch. Pixel pitch refers to the center distance between two pixels. It is a term widely used in the LED industry. The finer pixel pitches, the more contents can be displayed in the same area. Then it is the pixel per inch, refers to the number of pixels in a unit area, usually measured by the number of pixels in the square millimeter. Then number of scans. Number of scans means the dataset needs to scan a number of rows to complete a row round. With the increase of scanning number, the quantity required for driver IC is less, and the module cost is lower. Hence, the display effect is getting worse. When a dataset completes a round of scanning, it is called a one refresh, and the number of times to complete a refresh in 1 second is called a visual refresh rate. The greater the refresh rate is, the more stable the LED display. And then, the refresh rate refers to the rate to the display is updated, usually expressed in hertz. 30 Hz means the display update is image 30 Hz per second. And here comes the very important one, calibration. Calibration is an important concept in the LED industry. The LED display is limited by discreteness of existing raw materials, the immaturity of existing technology, and aging and mutation of LED screens. Therefore, the uneven problem for LED display is widespread, hence calibration is needed. Now let's look at these pictures. Here is the color gamut distribution before and after calibration. As you can see, the chromaticity of each LED lamp is compensated point by point. The LED display effect is greatly improved. Here is the brightness distribution before and after calibration. And here is the display effect before and after calibration. Well, the grayscale level is the brightness level range of the grayscale image. Briefly, it refers to how many brightness levels the display screen can have from full black to brightest. The larger the grayscale level is, the more delicate the screen will be. Well, that's all about today's course. Thank you so much.